we're going to go over the logarithmic mean temperature difference, specifically how to calculate it in the design of heat exchangers. So it's used when we design heat exchangers for pure countercurrent or co-current flows, and this is the equation on how to calculate it. So we assign either, for example, if we had a shell and tube heat exchanger, we would assign the shell as T1 and the tube as T2. So the difference, delta T1, is basically the difference between the inlet temperatures if it's co-current, or the alternate temperatures if it's countercurrent. I'll do an example just to clarify. So if we assign this bit as 1 and 2, using our equation above, delta T1 is 60 minus 15, which is 45. So you have 45 minus delta T2, which is 5, divided by ln delta T1 over delta T2. So put that one in the calculator. Our logarithmic mean temperature difference is 18.2. So this is important because the temperature does change as the fluid is in the heat exchanger. So when you're calculating things such as heat transferred, it's quite hard to find a value. So we use the logarithmic mean temperature difference. If we do another example, but for countercurrent flow, so this is where the fluid directions are opposing. One goes this way while the other goes this way. So there's, as we can see here, there's kind of like a constant temperature gradient, a bit more efficient than this. So if we calculate for the countercurrent flow, we have delta T1, we'll call this side 1, this side 2. So delta T1 will be 60 minus 25, which is 35, minus 30 minus 15. And we do the same thing again. 35 minus 15 over ln 35 divided by 15. We have a temperature of 23.60. So as you can see, we have a higher logarithmic mean temperature difference for a countercurrent flow, even though we still have the same numbers involved, i.e. 60 to 30 and 15 to 25, but they're just going in the opposite direction. So that's how you calculate the logarithmic mean temperature difference.